Let's get started with chi-square, or chi-square, sounds better. So here's this batch of mixed nuts, and let's see, 52% cashews, 27% almonds, 13% macadamia, and 8% Brazil nuts. And they took a sample of 150 nuts to test this. And they found, let's see, what was it? Here is our observed data. And what did they ask us? State the appropriate hypothesis for performing a test of the company's claim. Let me write that out right now. So we can start with this, where we just say the null hypothesis is we just write out the proportion of cashews. See, probability of getting cashews is 52%. Probability of getting almonds is 27%, 13%, 8%, and so on. Or you can write this. The null hypothesis is that the company's claim for the distribution of nuts is correct. Either one of these will work, or you could write both of them. That would be just fantastic. And the alternative hypothesis is that one or more of these categories is not correct. Now, it doesn't have to mean that all of these are wrong. It could just mean that just the Brazil nuts are off. So that's important. One or more of these categories doesn't fit. Okay, that is the hypotheses for the situation. Now let's calculate the expected counts for each type of nut. And here is what we should expect. So for the cashews, we should get around 78. And the next one is the almond should be 40.5. The next one was the macadamia. We should get 19.5 on average if we did this over and over again. And then the last one was the Brazil nut, which should be 12. So this is our expected value. And then we might actually take a sample of 150 and compare what we actually see to these expected values. Anyway, so that's number one. Number 3 says, let's continue and get the chi-square number. Remember, it's the observed minus the expected, and we square that number and divide it by the expected. So here's the observed for each nut: cashew, almond, macadamia, Brazil nut. And then this is what was the expected value. We're going to subtract those and then square them. So here they are subtracted, and now I'm going to square them. So here they are squared. And we need to remember that we're going to take this number and divide it by the expected value. Each one of these divided by each one of those. And then we're going to add that together and get a final number. So let's look at what that looks like. Okay, so I did that. I divided those two numbers. Now what I did is I'm going to add them all together. So this number, this number, this number, this number. And I get, what do I get? 6.59. 6.59. That number is the chi-square. Remember, the larger this number is, the more we are off from what we expect. Okay, so that's all they ask us for number 3, is just the chi-square number. There it is. Number 5. Confirm that the expected counts are large enough to use a chi-square distribution. Now, in these problems, we're still going to do random, normal, independent. And the random and the normal are basically the same that we've always used. Now, the normal part is when we look at each category, and when we have our sample, we have to have at least 5 in each category. In other words, when we take the 150 nuts out, there have to be at least 5 of each type of nut. Otherwise, we can't do the problem. So at least 5 cashews, at least 5 almonds, at least 5 Brazil nuts, at least 5 macadamias. Okay. And now what was the degrees of freedom? We had 4 different nuts. So the degrees of freedom is going to be 1 less than how many categories we have. So the degrees of freedom is going to be 3. Now if you look at page 683, they have different degrees of freedom and the chi-square graph. And notice that it starts from 0, because we're seeing how far we are off, so we can't be off by a negative number. And it looks like for 3, it might look something like this, sort of. And I think that we're going to have a peak like this. So that's 1, 2, 3, 4, 5, 6. Okay. Let's look at letter C. Use table C to find the p-value, then use your calculator, and that is the chi-square CDF command. So let's just use the calculator. So in the calculator, I'm going to go to second and vars and down to chi-square CDF, just like they say. And the lower is going to be 0, and the upper is going to be, and the upper is 6.59, like we did from the earlier problem. Degrees of freedom is 3, and we take a look at what that says. So it's 0.9138. So that's the number that I get, 0.9138. So if we look at our graph, 6.59 is like this, and we want to say, what's the probability that we're that much off or more, right? So this, again, tells us the area to the left, over on this side. So we're going to subtract that from 1. And we get, this is our p-value, which is 0.086. What would we conclude? Well, it's the same thing that we always do. We say, well, at an alpha level of 0.05, this number is too big, so we fail to reject the null hypothesis. We do not have enough evidence to refute the claim that those percentages of those nuts are different from what the company says. Blech. They're done.